Question 23, merge k sorted list. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted list and return it. So these are this is an example that we have 3 lists and they're all sorted. We are going to merge them all together and return one big list as a result, and the final result is going to be sorted as well. And if we don't have anything in the linked list, we are going to return an empty list. So let's see how we are going to solve this problem. One easy way to solve this problem, but not the most efficient one, is going to be the brute force. Let's go through an example. Let's say this is the example that we have, right? Let's say this is the example that we have. I'm going to add like 1, 6, and 9. Okay, here. So what we can do, we can have a new list. We are going to put the first linked list in it because we don't want it to be empty, and then we are going to have a pointer pointing at the beginning of the list. So we go through the second list and we compare the elements that we have in here with this one. But what will happen after I need to compare every single item that I have in the output? This is going to be the output, right? I need to compare every single item that I have in the output every single time, right, with the list that I am merging with the output. So let's say I check I is smaller than, if I is smaller than or equal to 1, it is. So I'm going to just add 1 here, and then I will check 1 is not bigger than 3. I go to the next one, I check 4 is bigger than 3, so I'm going to add 3 here, and then I will check 3 is smaller than 4. I move forward, 4 is not smaller than 4, it's going to be equal, so I'm going to add 4 here, and then we are done with this list, right? We go for the third list. We cannot start from the middle, right? We need to go again from the beginning and compare every single item that I have here with this one. So I check 1 is smaller, 1 is smaller, 3 is bigger. I'm going to put 2 here, and 2 is smaller, 3 is smaller, 4, 5, and I'll go all the way to the end and add 6 here. As you see, for the next one, I need to move this pointer again to the beginning. So every single time that I'm traversing this output list, and the time complexity for this is going to be n log n, and the space complexity is going to be linear because we are going to have a list of lists, like a list of all the elements that we have in here. But what we can do, we can do something better. We can we can use divide and conquer. What I mean by that, we can break down this problem into a smaller problem. How can we do that? Like, the easy way to do that is like, I'm going to merge this list, right, with the, for example, the last one or the one beside it. I'm going to merge it with the last one, right? This is what I chose. You can do with the one beside it. And then I'm going to merge the second list from with the list that we have, the second list from the end, right? And then I'm going to merge at the end the output of this with the output of this. So this way, instead of like traversing like every single list a couple of times, I'm going to do it very like with 3 move. I can make these lists all merged together and sorted. So, and the space complexity for this is going to be linear because when I merge the first one with the last one, I'm going to put these elements here, right? So these are gone. All the elements are merged to the first one. And when I merge this one with this one, all the elements from here will be gone and are going to be here. And because it's a linked list, it's just the pointer that we are moving around, right? And at the end, when I'm like merging the output of this and the output of this, is going to be all merged to the first one. So now that we know how the divide and conquer works for this problem, let's start coding. What we can do, we can have a merge toList function, so we can just call it easily. So it's going to be a cleaner code. Let's have a function for merge two lists. Merge two lists, right? I'm going to have self list 1 and list 2. Two lists are given, and I'm going to merge it. How am I going to do that? I'm going to say, I'm going to use dummy node because it makes it much easier. So I'm going to have a head, and I'm going to have node 0. I'm going to have a dummy node 0. And I will start, I'm going to say, as long as we have values in list 1 and in list 2, we are going to check if L1.val, this is what we are going to use, this class we are going to use. If the L.val is smaller than or equal to L2.val, we are going to say the head.next is going to point at L1, and L1 is going to move one step forward, L1.next, and then otherwise, which means it's smaller, we are going to say head.next is going to point at L2, and L2 is going to go one step forward. And after we are done with this, if definitely we need to move head one step forward as well, head.next. And the output of this, after being done with the while loop, return dummy.next. What we need to deal with, there is a special case here. Like the length of L1 and L2 is not going to be always the same. So we should consider that, and we should check if after we are done with this while loop and L1 and L2, one of them are not empty yet, right? So we are going to say if L1, we are going to say head.next is going to be equal to L1. And if L2, which means there are still nodes left in L2, head.next is going to point at L2. So this is the special case that we had to deal with. And now, I'm going to clean this so you have a clear code. Now, let's see how we can use this function in here. What we can do, I'll deal with the special case first. I'm going to say if length of list is equal to 1, there's nothing to do. I'm going to just return list at index 0 because there's only one list. Otherwise, I'm going to say n is going to be equal to the length of list, which is, or I'm going to use k. K is the number of lists that we have, right? And because in this is our starting from 0, I'm going to say -1. And then I'm going to have an interval. What is the interval for? Because we are going to like merge them 2 by 2, right? So we need to have an interval because this is going to happen logarithmically. So I'm going to say while the interval that I have is smaller than or equal to k, which means we are not done with all the lists, I'm going to, what I'm going to do, I'm going to have 2 pointers, right? I'm going to have, because these pointers are pointing at the list that I'm going to merge together. I pointer and J pointer. I pointer is pointing at the first list, and J pointer is pointing at the second list. So it starts from index 0, and J pointer is start from the n that I have divided by interval, right? I will give a few examples on this later so you can better understand. So while I is smaller than j, so it means they have not crossed each other, right? I'm going to say lists at index I, we are going to update this, right? So we are not going to create a new one. We are going to just update the list that we have at index I, right? I'm going to call the merge to list function that we just built up there. And what two lists I'm going to call? The one that I pointer is pointing at and the one that J pointer is pointing at. And then after we are done with this, I'm going to move I one step forward, J one step backward, and we are done with this. Now we need to update the interval as well, right? Because we don't want to merge same things over and over together. Especially after doing this, those lists are going to be empty, right? So we are going to multiply that by 2, and then we are done. What we are going to do, we are going to return list at index 0, because we are all merging them all at index 0, the list that we have index 0. And we are going to say list if the n that we have is bigger than 0, so it means it's not empty. Otherwise, we're just going to return none, right? Else we are going to just return none. Let's run this and see it works. There we go, it works. And I wanted to give a few examples here so you can better understand. So let's say we have a list of 1, 2, 3, 4, 5, 6, right? How many lists do we have? 7, but the index starts from 0. So what will happen? We are going to get the 0. This is what we are going to merge. We are going to merge 0, and what is n is the length of this list minus 1, which is going to be 6. 6 divided by 1 is going to be 6. So we merge these two, right? And then we are going to merge 1 and 5. And then we are going to merge 2 and 4, right? And then like I is not going to be smaller than 4 because they are both pointing at 3, and then we are done. So the output of this, the 0 and 6 are going to, you see, we are going to put it at index like I, right? So when we merge, these two are going to be merged at index, at least at index 0. And these two are going to be merged at index 1, and these two are going to be merged at index 2. And then we are going to merge them again. So we are going to merge 0 and 2, and because this is going to be the I pointer and J pointer. So now if we cannot do this because I and J are going to be equal. So we're done. And the output is going to be at index, we have 1 here, and output of these two is going to be at index 0. And then we are going to merge these two, which is going to be 0 and 1. And the output is going to be at index 0. That's why we return 0. And the space complexity for this is going to be constant because we are not using extra space. We are just moving the pointers around, and the time complexity is going to be n log k because we are going to do these log k times, like the breakdown, and we have n elements. Thank you.